All right, students, this is chapter 9, which is titled Reconstitution of Powders or Crystals into Liquid Medications. This is lecture 1 for chapter 9. As a disclaimer that I use for all of these lecture videos is that you should have already read chapter 9 within your book. You should have already reviewed the chapter 9 PowerPoint and the chapter 9 lecture notes that were provided to you guys within Blackboard. So at this point, we can move forward, and basically what I'm going to do right now within this lecture is I am basically going to just give you some basic information in identifying certain components to a medication stock label when solving these powder drug problems. So first things first is that when you look at a label, and let me be detailed, when you look at a stock medication label, you should be able to identify a couple of things. First things first is that you should be able to identify what we call the dosage strength or dosage concentration. Well, in this case, the dosage strength for this Amoxil is 125 milligrams per 5 milliliter. This is what you will call the dosage strength, or you may hear it be called the concentration. Okay? The next thing that you should be able, well, before I move on, well, what is dosage strength? What is the concentration when it comes to the reconstitution of powdered medications? Well, first things first is that if you have ever had to take amoxicillin oral suspension, you received that medication from the pharmacy. When you received it, it's already in its liquid form. But when we work in the pharmacy department, the amoxicillin oral suspension is not in its liquid form. We, as the pharmacy staff, have to reconstitute, or in other words, mix the medication with a diluent. And the diluent can either be water, sterile water, distilled water, sterile water for injection. But that water or that diluent is added to the powder to get to this dosage concentration. All right. So another component that I want you guys to be able to identify is that when you're looking at this label, you should be able to identify the final volume. In this case, this 100 milliliters is the final volume. And I'm going to put in parentheses FV, and you'll understand why as we go into more detail of solving these problems. But your final volume basically consists of two components. Your final volume consists of your powder volume and your diluent volume. So PV is powder volume and DV is diluent volume. Those two components added together will give you your final volume. All right. The next component that you should be able to identify when looking at the label is that you should be able to identify the diluent volume. So in this case, this total 78 milliliters is the diluent volume. In parentheses, I'm going to put DV. That's the diluent volume that should be added to the powder in order to get to the dosage concentration of 125 milligram per 5 milliliter. All right. Now, I've written all over this label, but I'm going to start erasing some things because there's some other components that you should be able to identify. So far we've been able to identify the dosage strength. which in this case is 125 milligram per 5 milliliter. You should be able to identify the final volume. In this case is 100 milliliters. But remember, the final volume consists of two components. It consists of the diluent volume and the powdered volume. You should also be able to identify the diluent volume. In this case is 78 milliliters. But another thing that I want you to be able to identify is that you should be able to identify in detail what diluent you need to use. So where will you find that information? Well, you will find it under the instructions where it says directions for mixing. And if you see here, it says add approximately 1/3 amount of water. So in detail, this water is your diluent. So if I ask you what diluent are you to use, you would tell me water. If I ask you what volume of diluent should be added to the medication, you're going to tell me 78 milliliters. All right. Another component that you should be able to identify, sometimes you can identify it, sometimes you can identify it from the label, and sometimes you may not be able to identify from the label. But that component is called the total dosage. Well, what do I mean by total dosage? Well, when I say total dosage is the total, I'm not spelling today, sorry. But the definition of total dosage is the total amount, or the total weight of powder. How about that? That's better. That's a better definition. So the total dosage is the total weight of powder, or in parentheses I'm going to say drug, within the container. Well, sometimes you can identify that on the label. All right. Well, if I look to the right of this label, and right here where it says net contents, it says equivalent to 2.5 grams of amoxicillin. That 2.5 grams of amoxicillin is your total dosage. So this 2.5 grams is the total dosage within the container. But remember, I just said that sometimes that's easy to identify and sometimes it's not. Sometimes it's on a medication stock label, sometimes it's not on the medication stock label. Well, the question is, if it's not on the label and you have to determine what the total dosage is, how do you do that? Well, in order to calculate total dosage, you will have to take the final volume over the volume of concentration, or I'm going to say in parentheses strength, and multiply that by the weight of concentration. In parentheses, I'm going to put strength. All right. Well, I can calculate that. Well, let me see if my calculations are correct. So if I calculated that, my final volume, we determined that the final volume is what? 100 milliliters, correct? So if I calculate that, I'm going to take 100 milliliters over, what's the volume of concentration? The volume of concentration, well, when I ask you what's the volume of concentration or what's the weight of the concentration, you look at your your dosage strength or your dosage concentration to answer that question. The dosage volume is that 5 milliliters. So that dosage volume is 5 milliliters. And you're going to multiply that by the dosage weight. Well, the dosage weight is 125 milligrams. Milliliters cross out. That gives you 2,500 milligrams. And in parentheses, I'm going to put 2.5 grams. Anytime a problem asks you to provide the total dosage, you always give your answer in grams. All right. So again, sometimes you're able to identify the total dosage from the label, and sometimes you have to calculate the total dosage from the label by taking the final volume, dividing it out by the volume of concentration, and multiplying it by the weight of the concentration. All right, so let's keep going. So the next thing is that if someone asked you, by looking at this label, could you tell me if this label was a single concentration or a multi-concentration medication? What will your answer be? Well, first you may ask me, well, Ms. Cahiga, what does that mean? Well, let me tell you what that means. A single concentration medication means that when you add your diluent volume to the powder, do you get one strength concentration, or do you get multiple strengths concentrations? So in this case, when I add the 78 milliliters, how many dosage strengths do you see? Do you see 1, 2, or 3? Well, in this case, you see 1. So that means that this label is a single concentration medication. All right. Again, whenever you add the diluent volume to the powder that's in a container, if you get multiple dosage strengths, that means that this is a multi-concentration medication. If you only get one dosage strength, that means it's a single concentration medication. So in this case, the amoxicillin is a single strength or a single concentration medication. All right. All right, so that is the end of lecture 1. I'm going to pick right back up in lecture 2. But as usual, if you guys have any questions or if you want me to go over anything that was discussed in this lecture, please don't hesitate to send me an email. So the more practice you guys get and the more questions you ask me, you'll do just fine on your exams.